Hello everyone, welcome to my YouTube channel. I am Dr. D. Sridevi, working as Associate Professor in the Department of IT from SRM Valliyamma Engineering College. In this lecture series, we are going to learn cloud computing in a simple and structured manner. This series will help students to understand core concepts and it will help for the exam-oriented topics and practical applications of cloud computing. Thank you all. Welcome you all. Welcome to Cloud Computing course. Here we are going to discuss about introduction to cloud computing, then definition of cloud, then evolution of cloud computing, then what are the various underlying principles of parallel and distributed computing, then what are the various characters of cloud, then what is elasticity in cloud, then at the last on-demand provisioning. So here we will move to the introduction to cloud computing. So here cloud computing is a technology that allows you to access computing resources such as servers, storage, databases, software and networking over the internet, and instead of owning and maintaining physical hardware we can use cloud computing. In simple words, you use IT resources as a service just like electricity or water, and you can pay for what you are going to use. So or what you use you can pay for it. Similar how we are paying our electricity bill, in same way we can pay for the cloud computing usage. Then what is the need for this cloud computing? Then traditional computing requires buying servers, then you need to install the software, then we need to maintain the hardware, then high upfront cost are the basic or traditional computing requires. But in the cloud computing, it removes all these difficulties by providing on-demand services through the internet. So what are the various key characteristics? On-demand self-service, then broad network access, then resource pooling, then rapid elasticity, then measured service or various key characteristics of cloud computing. Then we will move to the definition of cloud computing. So here uh, what we discussed in the introduction is pay per use. Similarly, the definition, simple definition is on demand service and we pay for what we used. Okay. So this is how the definition of cloud starts. Here the cloud computing has become a buzzword. It has been widely used to refer different technologies, services and concepts. It is often associated with virtualized infrastructure or hardware on demand, then utility computing, then IT outsourcing, then various platform and software as a service, and many other things that are now focus of the IT industry. Then the term cloud computing refers to services provided by the cloud that is responsible for delivering of computer services such as servers, storage, databases, even networks, then software, then analytics, then intelligence, and moreover all through the internet. So that is the basic need for our cloud computing. Without internet you cannot do anything. So very basic requirement is of internet. Through internet you can do anything by using cloud technology. So what are the various advantages of cloud computing? Means the cost is of very low, then you need not if you are going to start, for example, if you are going to start a startup, what are the various requirements you need of we need to invest for the systems, buying of hardware and software. So if it is going to be reduced, then the cost will be of very minimum only. If you are going to use this cloud computing, then we need not buy all these things. We can just use Whenever there is a demand, you can have a cloud computing, and it is going to serve you for based on your requirements, and you later you can pay for it. So that is the advantage of cloud computing. Then speed is of very high, then scalability is more, then productivity, then reliable, it is of highly secure. So these are the various advantages of cloud computing. Then how this cloud evolved? The idea of rendering computing services by leveraging large distributed computing facilities has been around for a long time. Not only nowadays, it is of from early 1950s itself. In days back to the days of the mainframes in early 1950s, from there on the technology has evolved and been refined. This process has created a series of favorable conditions for the realization of cloud computing. Then in 1950s, the first mainframe ENIAC emerged, then supercomputers, then ARPANET in 1970s, ARPANET, then you'll be having TCP/IP, then in 1980s, Ethernet IEEE 802.3, Ethernet and LAN. Then in 1990s, around 1984, this VM virtual machine clusters arose. Then in 1990s, www, then HTTP, HTML arrived. Then in 1999, grid computing concept emerged. In 2004, Web 2.0. In 2005, Amazon AWS. In 2007, Microsoft Anega. Then in 2008, Google's App Engine. In 2010, Microsoft Azure. These are the various technologies emerged. This is how the evolution of cloud computing. So here this Microsoft, then Amazon, Google, or the vendors, they provide the services of various services. The cloud basically provides various services like software as a service, platform as a service, and application as a service. So these are the various services here: infrastructure as a service, then storage as a service, network as a service. This and all now emerged very well. So before that, these are the basic three services provided, and the Microsoft Azure provided. Azure is the service, and Google App Engine, and AWS is by Amazon. These are the various services provided by various vendors, and this is how the cloud computing evolved. And here the basically first one is of distributed systems, then virtualization concept, then Web 2.0, then service oriented computing, then utility oriented computing. In distributed systems, clouds are essentially large distributed computing facilities that make available their services to third parties on demand. As a reference, we consider the characterization of a distributed system proposed by Tenenbaum-Mettel. A distributed system is a collection of independent computers that appears to its users as a single coherent system. So here we are going to it is going to appear as a single coherent system only, but it is of a collection of different many number of independent computers. Then next one is of mainframes, then clusters and grids. The next concept is of virtualization. The virtualization not only what it is not the concept now recently emerged. It is of concept being 40 years. It came before 40 years itself. Its applications has always been unlimited by technologies that did not allow an efficient use of virtualization solution. Then virtualization, it is going to take confers the degree of customers control that makes cloud computing appealing in front, at the same time sustainable for cloud services provided. Then this is of another core technology for cloud computing, the virtualization. Without virtualization concept, there is no cloud computing. Then Web 2.0, it is going to it only it brings the interactivity and flexibility into web pages, providing enhanced user experience by gaining web-based access to all the functions that are normally found in desktop applications. Without this web 2.0 is nothing done. So it is of very important for cloud computing technology. These capabilities are obtained by integrating a collection of standards and technologies such as XML, asynchronous JavaScript, and XML Ajax, then various web services and others. These are for building various applications by the users, and it is of various users also. And next one is of service oriented computing. So here service orientation is a core reference model for cloud computing system. This approach adopts the concept to various services, main building blocks of applications and system development. Then next is of quality of service, that is very important. Without quality, any service is said to be nothing. There is no use of any service provider without, if there is no quality, then there is no it is not required also. Without quality, there is no use. So that is very important. Quality is of very important. Then concept of software as a service. So here the very basic or well-known application or example of this service, software as a service, is email. Email provided by various vendors, and we will be using it very well. We all know this software as a service, that is email concept. Then the quality of service identifies a set of functional and non-functional attributes that can be used to evaluate the behavior of a service from different perspectives. Then what are the various requirements QAs are established between client and the provider via the SLA is nothing but the service level agreement that identifies the minimum values for QoS attributes that are needed and satisfied upon service call. The SLA plays a very important role. Then in this I will be having a agreement between the what are the various services will be provided, that is given as the agreement between the client and the who is going to provider. So that is SLA. Then quality of service is provided. Then concept of software as a service. So here it introduces a new delivery model for applications. The term has been inherited from the world of application service providers, which deliver software services based solutions across the wide area network from a central data center and make them available on a subscription or rental basis. Whether you can subscribe or you can make it as a rental, you can pay, or you can pay monthly or 3 months, like that you can pay for it. That is a rental basis, or you can subscribe like that. These are the various options available, and the ASP is responsible for maintaining the infrastructure and making available the application, and client is freed from maintenance cost and difficult upgrades. Then the SaaS, that is software as a service approach, reaches its full development with the service oriented computing, where loosely coupled software components are exposed and priced singularly rather than entire application. So if you are going to use for a particular model, so module, then you can pay for it like that. If you are in need of only one component, you can use it and you can pay for it. For example, if you are going to use if you want to do any changes in your for example in your photo, okay, or if you are going to take any image and you want to do any work on it, or if you want to edit that, then you can go for this Photoshop for 5 minutes or 10 minutes. So you can take whatever the advanced software available. For example, Photoshop, you can rent it and you can use it. Then that is very what it is very cheap, and also it is not going to occupy your system. So everything is advantageous when you are going to use this service, software as a service. So that is the advantage of this cloud computing services. Then utility oriented computing. So if you are for example, if the computers of the kind I have advocated become the computers of the future, Then computing may someday be organized as a public utility, just as a telephone system is a public utility. So computing utility could become the basis of a new and important industry. It is very very important. So if you want to get advanced in the technology, it need to be available for everyone. So that is how the telephone become uh, available for the public utility. Then only this communication problem and all overcome. Similarly, at the end of this telephone system version, you are having this mobile. So it is of very good what without nowadays we cannot live without mobile for even fraction. So that is the advantage of the technology. Then next we will be discussing about underlying principles of parallel and distributed computing. Then what are the errors of computing? Then what is parallel versus distributed computing? Then what are the various elements of parallel computing? Then what is parallel processing? Then next topic is of hardware architectures for parallel processing. Then we will be discussing about shared memory MIMD machines, then distributed memory MIMD in machines. There's multiple instruction, multiple devices machines. Then the elements of distributed computing. Then general concepts and definitions. Then what are the various components of a distributed system? So here, more than that, you will be having these more small topics we will be discussing. Then first one is of next one is of cloud characteristics. Cloud characteristics of seamless creation, and it uses third party services. Then clever safe storage, on demand provisioning, that is a basic character of cloud computing. Then what are the various eras of cloud computing is of here you will be having two fundamental and dominant models of computing, that is of sequential and parallel. The sequential computing era began in 1940s. The parallel, that is under distributed computing era, follow edit with a decade. Then four key elements of these developed during these eras are architectures, compilers, applications, and problem solving environments are the four key elements. Then parallel versus distributed computing. Here the parallel computing implies a tightly coupled system, whereas distributed refers to a wider class of system including those are tightly coupled. Then parallel computing and distributed computing are often used interchangeably, even though they mean slightly different things. Then this is how the parallel versus distributed computing. Then this is of parallel era problem solving environments. You will be having applications, then compilers, then of architectures. Here first is of problem solving, then the application. You can see how it emerged. Then next one is of elements of parallel computing. So here you will be having uh, very good challenges in this. It is now clear that silicon based processor chips are reaching their physical limits. So processing speed is constrained by the speed of light, and the intensity of transistors packaged in a processor is constrained by thermodynamic limitations. So we'll be moving. The viable solution to overcome this limitation is to connect multiple processors working in coordination with each other to solve grand challenge problems. So this is a challenge phase, and this is how it is going to solve this grand challenge problem. Then this first step in this direction led to the development of parallel computing, which encompasses techniques, architectures and systems and performing multiple activities in parallel. So what is parallel processing? So it is going to process multiple tasks simultaneously on a multiple processor is called parallel processing. So parallel processing is nothing but it is processing of multiple tasks simultaneously. For example, if you are going to use mobile, if you are going to use laptop, so we will be parallelly you will be taking printout, parallelly you will be what hearing some songs. Parallelly, you will be doing some other works. So this is of multiple tasks you will be doing simultaneously on a multiple processor is called this parallel processing. Then this parallel program consists of multiple active processes simultaneously solving a given problem. So a given task divided into multiple subtasks using a divide and conquer technique, and each subtask is processed on a different central processing unit. So for example, if it is going to be, for example, if you want to sort, okay, how we can sort if it is going to be a 10 digit 10 numbers, okay, 10 numbers in the given problem. So you need to sort the elements, 10 elements. So first you have to split this into 5 elements in the left and 5 elements in the right. Okay, that is divide. Then in the 5, then again it is going to be 3 2, and here 3 2. Then it is going to be what you need to arrange the elements. So as the problem is of sorting, so we need to arrange the problems. This is how the divide steps, and it is the next step is of conquer, or that is the merge. Then you have to merge this 3 2 and 5, and this 5 into 5 to 10. So this is how it is going to be divide and conquer technique. Here also the problem or the task is divided into subtask, and it is processed on a different central processing unit. Programming on a multiprocessor system using the divide and conquer technique is called parallel programming. Then what are the various hardware architectures for parallel processing? These are the four categories: single instruction, single data, and single instruction, multiple data, then multiple instruction, single data, then multiple instruction, multiple data. This is how the hardware architectures for parallel processing. Then this single instruction, single data is of computing unit is a uniprocessor machine capable of executing a single instruction which operates on a single data stream. Okay, single instruction, single data. Then single instruction, multiple data. Here, single instruction, multiple data is a multiprocessor machine capable of executing the same instruction on all the CPUs but operating on different data streams. Machines based on a SIMD, that is single instruction multiple data model, are well suited to scientific computing since they involve lots of vectors and matrix operations. For example, here you will be having processing all the elements, and it is how it is going to process. A and B can be divided into multiple sets, and each P can process on one data set, that is P years of processing elements. Then Ci equal to A into Bi. This is how it is going to do process. Then multiple instruction single data system, y equal to sin of x plus cos of x, then plus tan x. So this is how it is going to process multiple instruction single data system. Then multiple instruction multiple data system. Unlike this two SIMD and MISD, it the piece that is processing we discussed processing elements in MIMD machines work asynchronously. MIMD machines are broadly categorized into shared memory and distributed memory. MIMD based on way P's are coupled to the main memory. The next, shared memory MIMD machines. In the shared machine memory MIMD model, all the P's are connected to a single global memory and they all have access to it. That is the advantage of this. Then systems based on this model are also called tightly coupled multiprocessor system. The communication between P's in this model takes place through the shared memory. How the communication takes place means through this shared memory only the communication takes place. Then the modification of data stored in the global memory by one P is visible to all other P's. So it is obvious that is it is going to share the memory, and it will solve visible to other P's also. Then next one is of shared memory, MIMD machines architecture, how it is going to work. Then next one is of shared one left and a distributed one right, and MIMD architecture is of left and right is of shared and distributed memory. Then you will be having distributed memory, MIMD machines. The shared memory MIMD architecture is easier to program but is less tolerant to failures and harder to extend with respect to the distributed memory MIMD model. Failures in a shared memory MIMD affect the entire system, whereas this is not the case of the distributed model, in which each of the P's can be easily isolated. That is the advantage of this shared one. Then moreover, shared memory architectures are less likely to scale because the addition of more P's leads to memory contention. That is the small drawback of this one. Then this is a situation that does not happen in the next one, distributed memory, and in each P it has own workspace, and as a result distributed memory architecture is popular today. Then what are the various elements of distributed computing? We extend these concepts and explore how multiple activities can be performed by leveraging systems composed of multiple heterogeneous machines and systems. We discuss what is generally referred to as distributed computing and more precisely introduce the most common guidelines and patterns for implementing distributed computing systems from the perspective of software designer. Next one is of general concepts and definitions. This definition is general enough to include various types of distributed computing system that are especially focused on unified usage and aggregation of distributed resources. So here it is of components of a distributed system, a layered view of a distributed system. Here you will be having various layers, networking and parallel hardware, then IPC and primitives for control and data, then frameworks for distributed programming. This is how. Then here you will be having hardware in the base, and next one is of operating system, then middleware, then at the top you will be having various applications. So this is how the components of distributed system, and this is the layered view of your distributed system. Then what are the various architectural styles for distributed computing? So here you will be having two major classes, software architectural style and system architectural styles. These are the two. Then you will be having components and connectors. It is the component represents a unit of software that encapsulates a function or a feature of the system. For example, of this component is of can be programs, it may be a object, it may be processes, pipes and filters. Connectors is a communication mechanism that allows cooperation and coordination among components. So this is what the component and connectors. Then next one is of software architectural style. The software architectural style are based on a logical arrangement of software components. They are helpful because they provide an intuitive view of the whole system despite its physical deployment. So these models constitute the foundations on top of which our distributed systems are designed from a logical point of view, and they are discussed in the following sections. Then data centered architectures, this is mainly it is going to identify the data as the fundamental element of the software system. So this is how the data centered architectures. Then data flow architectures with respect to the data center styles in which the access to data is a core feature. Data flow styles explicitly incorporate the pattern of data flow since they are like a dam flow, since their design is determined by an orderly motion of data from component to component. This is the form of communication between them. Styles within this category differ in one of the following ways. How the control is exerted, that is the only what difference. The degree of concurrence among the components and the topology that describes the flow of data. Then this is how the data flow architectures And then it is what batch sequential style is characterized by this. Then the availability of data that controls the computation with respect to the data centered styles in which the access to data is the core feature. Data flow styles explicitly incorporate the pattern of dam flow. The next one is of pipe and filter style. This pipe and filter style is variation of the previous style for expressing the activity of software system as a sequence of data transformation. Each component of processing chain is called a filter, and the connection between one filter and the next is represented by a data stream. So this is how the pipe and filter style. With respect to batch sequential style, data is processed incrementally and each filter processes the data as soon as it is available on the input stream. The next one is of virtual machine architectures. The virtual machine class of architecture style is characterized by the presence of an abstract execution environment that simulates features that are not available in the hardware or software. So here, what is the comparison between your batch sequential and pipe and filter styles? Or batch is sequential, coarse grained. Here it is of fine grained. Here high latency. Here it is of reduced latency. Then here it is going to have external access to input. Here localized input. No concurrency. Here concurrency is possible. Then no non-interactive. Here it is interactivity awkward but possible. Then the rule based style. The next one is of rule based style. In this, the input data for applications is generally represented by a set of assertions or facts that the inference engine uses to activate rules or to apply predicates, thus transforming the data. The output can either be the product of the rule activation or a set of assertions that holds true for the given input data. So this is of this approach is of quite peculiar. Then top down style, here it is going to have a system developed according to this style or composed of one large main program that accomplishes its task by invoking subprograms or procedures. The components in this style are procedures and subprograms, and connections or methods, calls or invocation. The calling program passes information. Object oriented style. This architecture style encompasses. Next one is of architecture styles based on independent components. So this class of architectural style models systems in terms of independent components that have their own life cycles which interact with each other to perform their activities. There are two major categories within this class: for communicating processes and event systems, which differentiate in the way the interaction among components is managed. Then communicating processes. Components are represented by independent processes that leverage IPC facilities for coordination management. So each of these processes provides other processes with the services and can leverage the services exposed by other processes. The next one is of event systems. The components of the system are loosely coupled and connected. In general, other components provide a callback that will be executed when the event is activated. During the activity of a component, the specific runtime condition can activate one of the exposed events that triggering the execution and callbacks registered with it. So this is how the event systems. And then system architectural styles. Here it is going to cover the physical organization of components and processes over a distributed infrastructures. So this here it is going to what is going to provide a set of reference models for the deployment of such systems and help engineers not only have a common vocabulary in describing the physical layout of a system but also quickly identify the major advantages and drawbacks of a given deployment and whether it is applicable for a specific class of applications. In this section, we are going to introduce two fundamental reference models, client server and peer-to-peer. So here you will be having client server, thin client model, fat client model, two-tier architecture, three-tier architecture or n-tier architecture, then peer-to-peer concepts. So these are the various system architectural styles. Then message based communication. So if you are going to give one message, for example, this is very well known. The term message in this case identifies any discrete amount of information that is passed from one entity to another. How you are sending and receiving messages, same concept. This is message based communication. Then what are the various models for message based communication? Or point to point message model, then publish and subscribe message model, then request and replay message model. So point to point message model, you can take our WhatsApp also. Public and subscribe message model, we can take our YouTube. Then request reply message model, you can take as a client server model. Then here this model organizes the communication among single components. Each message is sent from one component to another, and there is a direct addressing to identify the message receiver. This is of point to point message model. Then publish subscribe is the push and pull strategy. Here you will be having push strategy and it is of going to have a pull strategy. So this is very suitable for implementing systems based on one-to-one communication model and simply implement the indirect communication patterns. Then request reply message is of identifies all communication models in which for each message sent by a process there is a reply. So this is of a request reply message model. Then what are the various technologies for distributed computing or remote procedure call and distributed object frameworks are the two technologies for distributed computing. Then this is how the RPC reference model. So here you will be having node A and node B. Then you will be having main procedure, then procedure A, procedure B. Then you will be having program A. Then you will be having RPC library. So this is how the node A processes and it is connected through the network and node B processes the same. Okay, this is how the remote procedure call. Then RPC is a fundamental abstraction enabling the execution of procedures on client request, allows extending the concept of procedure call beyond the boundaries of a process and single memory address space. The called procedure and calling procedure may be on the same system or they may be on different systems in a network. The concept of RPC has been discussed since 1976 and completely formalized by Nelson and Birrell in the early 1980s. So this is how the remote procedure call works and distributed object frameworks. This is how here distributed object frameworks extend object-oriented programming system by allowing objects to be distributed across a heterogeneous network, that is different network, and provide facilities so that they can coherently act as though they were in the same address space. Then distributed object frameworks leverage the basic mechanism introduced with RPC and extend it to enable the remote invocation of object methods and to keep track of references to objects made available through a network connection. This is how the distributed object frameworks. Here the common interaction pattern is of first one is of server process maintains a registry of active objects that are made available to other processes. Then client processes by using a given addressing scheme obtains a reference to the active remote object. This reference is represented by a pointer to an instance that is the same type of similar type of interference and class definition. Then the client process invokes the methods and it is going to calling them through the reference previously and it is going to obtain the what are the various parameters and it is going to return values. So this is how the distributed object framework works. Then this is how the node A and node B are connected and it is going to exchange the communication. Then what are the various cloud characteristics? So here you will be having various cloud characteristics. Some interesting characteristics also there brings benefits to both cloud service providers and also to cloud consumers and also to providers. So no upfront commitments, on-demand access, nice pricing, simplified application acceleration and scalability, efficient resource allocation, and energy efficiency. These are the various characteristics of cloud computing. Then seamless creation and use of third-party services. So the most evident benefit from the use of cloud computing systems and technologies is the increased economical return due to reduced maintenance cost and operational cost related to IT software and infrastructure. So the best example are work from home and the online classes, etc. So it reduced the capital cost. Then if you are going to become the entrepreneur, startup, if you are going to work with any startup, then this cloud computing plays a very important role in reducing the capital cost. Capital cost are the cost associated with assets that need to be paid in advance to start a business activity. Yes, as I told, here we need not invest. If you are going to be the startup, you need not have much more investment in the capital cost. So you can go with the cloud computing where you can lend software and hardware, and you can later you can pay for the what you used. So that is how your EB bill we are paying. Similarly, we can use the cloud in on-demand provisioning. Whenever there is a demand, only it is going to provide. So that is there is no wastage or there is no excess like that. It is going to be concepts. Here it is what the cloud storage systems have unique challenges that legacy storage technologies cannot address. Storage technologies based on RAID and replication are not well suited for cloud infrastructure because they do not scale easily to the exabyte level. Then this is how the unit 1 completed. Thank you all.